Hello everyone. If I give you any number below 100 and ask you whether it is prime or composite, you'll be able to tell me easily because of the help of the tables. But if I give you any number greater than 100, maybe 3 digit, 4 digit, and I ask you whether it is prime or composite, so it's not gonna be an easy task. So how to find out whether a given number is prime or composite? So let's learn this in this video. Okay, so let's take an example of number 137. If we have to find out whether it is prime or not, we have to see whether we can break it down further into prime components or not. That means, does it come in table of primes, any primes or not? If we fail to divide it by any prime number, then we can term it as a prime number itself. Otherwise, if we successfully able to divide it by prime number smaller than this, then we are actually able to break it down into smaller prime numbers and we can term it as composite. So let's start with the prime numbers. Okay, let's start with the very small, very first one, smallest prime number, that's your 2. Okay, then the next is 3, then there is 5, then 7, then 11, and till 100 there are 25. Okay, let's check by them. Is it divisible by 2? It's not divisible by 2 and 5. We know the divisibility rules. As one's place is 7, so it's neither divisible by 2 nor by 5. And as the sum of the digits is 11, so as per the divisibility rule of 3, it's not divisible by 3. 7, is it divisible by 7? You can actually divide it by 7. Dividing by 7 is not very tedious task. So 7 ones are 7 and the remainder is gonna be 6, and then we get 67, and 67 is not divisible by 7. So 137 is not divisible by 7. Let's divide by 11. 11 ones are 11 and the remainder is 2. And then we get 27, and 27 does not come in table of 11. So 137 is not divisible by 11 even. Now, there are many prime numbers greater than 11 and below 137. Are we gonna try with all of them? Actually not, because that's gonna be very lengthy work. So in this video, we will learn the shortcut. Initially, you can try with these numbers as this is easy, and later on we can switch to a technique. Okay, let's write down those numbers that appear in 13's table for the very first time. That means they don't appear in any of these table, but first time they appear in 13's table. So the very first number is the 13 itself. Okay, and the next number is not 2 into 13, because 2 into 13 means 2 is there in it. Okay, so the next number which comes in 13's table and not in any of these tables is 13 into 13. Okay, because 2 into 13 will come in this table, will come in 2's table also. 3 into 13 will come in 3's table also. 4 into 13 will come in 2's table also, because उसमें 4 है तो 2 भी होगा. 5 into 13 will come in 5's table. 6 into 13 will come in 2, 3 and 6 tables also. 7 into 13 in this. 8 into 13 in 2's table. 9 into 13 in 3's table. And 10 into 13 in 5's table, 2's table. 11 into 13 in 11's table. But 13 into 13 has the smallest prime number as 13. So it has very first time appeared in 13's table only. So 13 into 13 is your 169. Okay, now 13 into 13 is 169. The next number which very first time appears in 13's table, that means 13 is the smallest factor of it, is gonna be 13 into 17, and that's gonna be 221. Okay, so we have written 13's table till 17 and 137 has not come. 1 into 13 is 13. 2 into 13, if it would have 2 into 13, will have 2 in it, and this number is not divisible by 2, so not by 13 even. So we need not to divide it by 13. We can simply see that the numbers which have 13 as the smallest factor are 13, 169 and 221. That means 137 does not have 13 as the prime factor. Okay, so it does not come in table of 13. Will it come in table of next prime number, which is 17? Definitely not, because the number which are only divisible by 17 are this, and the next number is this, and the next number is gonna be bigger than this. So clearly 137 is not there. Okay, even the next prime number 19 would have first number 19, and the next number which is only divisible by 19 is 19 into 19, which is gonna be bigger than 289. So definitely that is not 137. Okay, so we can clearly say that 137 does not come in table of 13. It will not come in table of 17. If it would have appeared somewhere, no? So, and it will not appear in any other table above 17. So 137 is our prime number.